Hi, my name is Rob Atwill. I'm the Director of Veterinary Medicine Extension here at UC Davis. So this is a very short overview of a longer presentation entitled Rangeland Management of Waterborne Pathogens from Livestock and Wildlife. So a common question that we get in this area of waterborne infectious disease is, what role do livestock and wildlife have in contaminating water with pathogens? How does this happen in the first place? How do pathogens move from the terrestrial part of a watershed to the aquatic part of a watershed? And what can we do as landowners or managers to minimize the risk of waterborne contamination? So one of the first things that we want to cover in this very short presentation is, what do we mean by a pathogen? And we want to compare that to what's commonly used to regulate water is a bacterial indicator. So when we talk about pathogens, we want to be strict and say it really needs to be a microorganism that cause some type of illness, some type of poor health in humans. It needs to be shed by an animal. That's what makes it a zoonotic pathogen. So it needs to replicate in the animal. And the third thing is that this pathogen needs to be primarily transmitted through water as the route of transmission to humans. Many times we have foodborne transmission, so obviously those aren't going to be waterborne pathogens. We could probably agree the classic examples of waterborne pathogens here in the US would be the protozoal parasites Cryptosporidium parvum and Giardia. And typical pathogenic bacteria that might we be concerned about would be the enterohemorrhagic bacteria, commonly known as E. coli 0157 and other STECs. Other bacteria we'd be concerned about will be Salmonella and Campylobacter. So we can argue about which ones are most common, which ones are most important, but probably these top 5 are the ones we really need to address here in California and across the United States. In contrast, the way we regulate water quality with respect to microbial contamination is using indicator bacteria, which generally aren't pathogenic, are very common both in us and domestic animals and wild animals. So these are old 50-year, 80-year-old technologies, very much in need of updating, new ways to approach monitoring, but this is still the standard that's used at the county, the state, and the federal level is total coliform, fecal coliform, and what we might say indicator E. coli. They don't do a good job oftentimes, but that's the tools we have at hand. If we decide that we need to reduce the risk because of the importance on the water that's being used from this agricultural or rural watershed, we like to design and implement what we call beneficial management practices, something that the landowner, land manager can implement on the land, often at the landowner scale, that'll reduce the risk. So we need to know who sheds the pathogens to target these B&Ps, management practices. How does it reach the water? So how does the transport, how does connectivity when it rains, how does overland flow occur, and how can we prevent that using either strategic placement of livestock, exclude them from sensitive areas in the fall, or last resort perhaps is temporary or permanent fencing. While the pathogen is waiting to be moved from the terrestrial to the aquatic part of a watershed, it's often being environmentally inactivated. So how can we take advantage of that process? For example, maybe we exclude cattle on irrigated pasture 1 or 2 weeks before we irrigate. So what we'll talk about in the longer presentation is multiple approaches to develop these beneficial management practices based on local conditions and the need to improve water quality if you're in a situation where water quality is very critical to the community. So thank you very much.
For more information on this topic, we invite you to view a more in-depth presentation that provides science-based insights and conclusions. You can find this and other ranch water quality presentations on the UC Rangelands website, and look for the Water Quality Information Hub or direct your web browser to the URL shown on this slide.